Okay, guys, welcome to the final day of the course. We try to put in practice what we have seen in the last couple of days. As you have seen, C++ is a very rich, very powerful language, but also can be pretty complicated. And C++ is sometimes referred to as a multi-paradigm language, because it offers you the possibility to do different styles of code. So you can go from plain C style, and you can go to object-oriented, and you can go to what we've seen, what we will see today, generic codes. So each of these styles have different strengths and weaknesses, and object orientation, for instance, can be very valid if you are doing GUIs, user interfaces, interactive codes. There you might want to use object orientation. But object orientation, on the other hand, you start having this deep class hierarchies, and you have to understand what's the whole thing, and it might be slow because of virtual function calls and stuff like this. Straight C is great for performance and for reasoning about your code, because you can relate the code directly to your architecture. And generic programming offers you the ability of abstracting common things to be reused, and in a way that allows you these famous zero overhead abstractions. So you can really kind of reuse pieces of code and make them work for your benefit, and it also allows you also to reason about performance. It's a very powerful abstraction, and it is very useful when you are developing libraries for others, or you are developing components for yourself. Components are pieces of code that you will want to reuse over and over again, but with different customizations. And I will let Anton go in first, explaining you what the standard template library is, which is an example, basically, of generic code. And then it will explain you more about what generic programming is and how it can be good for you.
Slide. Yes. Yes, okay, let's start. So STL stands for Standard Template Library, and by the way, this so by the way, in the language documentation there is no such a term, and it is historical. And it's a part of standard library that was designed originally by Alexander Stepanov in 1994. And the strict definition of STL library is informal. It's everything in standard library that is around algorithms, iterators, and containers. Let's go deeper in details. So what? STL library. STL library operates with the concepts. So, and concepts are kind of interfaces, but unfortunately, in the C there is no way to describe the concept in a formal way. So is basically this. Each concept is a set of requirements for the class or any other type that you that it must satisfy. Usually, people say that type models the concept, and each STL entity models some concept, and all template parameters should be in STL, should model the correspondent concept too. So and the concepts in STL library are so the key concept is iterator, and containers, they implement iterators. To be precise, they implement functions that return iterators, like begin and end. And algorithms, they don't operate on containers directly, but they operate on iterators. And this forms the orthogonal structure of the library. So you can use the same algorithm with several containers, and of course containers can be and containers can be used with several algorithms. So, and you can extend that, yes, as far as you model the concept correctly. And there's no runtime overhead. So there is no virtual functions and inheritance in STL. The last important thing that about thread guarantees. So STL containers and are thread compatible but not thread safe. Do you know what is the difference? Okay, so thread safe means that you can use methods of the class in any thread without additional blocking, all methods. And thread compatible means that you can use without additional serialization all constant members, but for non-constant methods you should use synchronization mechanisms. Okay, let's how concepts are defined. The informal informally iterators STL iterators should behave as a pointer to as a pointers within C array. Like in this example, yes, I in this example behaves as an iterator, and in fact it's obviously the pointer. Well, if you can easily replace this data with the vector, and code doesn't change much. So we only have instead of so the only thing that we take from vector is begin and end methods that provide you the start and the end of your iterator range. So what does it mean to be like a pointer? You should provide some syntax. You should be, if you are an iterator, you should be able to move forward, backward. You should probably you should move anywhere in your range. Obviously, you need to dereference, and iterators should be comparable to each other. Otherwise, we don't know where the range ends, and it should be cheap to copy. And all this set of the requirements is called random access iterator. So basically the most powerful type of iterator. It's a concept. And if you do all that thing except moving in arbitrary direction, you implement directional iterator. If you exclude moving backward, this is forward iterator. Well, if you allow to dereference only for reading, and and you apply additional requirement that you can move only you can move through your range only once. It's input iterator. If it's the same, but that the reference only serves for writing, it's output. It's important to understand that this that syntax-wise, output, input, and forward iterator, they are the same. It's only semantic differences between them. This means that concepts are not cannot be described only syntactically. So the requirements are also semantic. That you and there's no other way than providing them with documentation or comments or stuff like that. Okay. So another important concept in STL is functor. It's anything that behaves like a plain function. Well, it should be callable and cheap to copy, and the state of the functor shouldn't change during invocation. So it's a call operator should be const. Well, containers requirements are much more complex, and to satisfy them, you should provide quite a few member functions of your class. For example, the most fundamental is begin and end, but there are others, size, empty, and so on. Well, if you have your data in container, and begin should point to the to the first element, and the end should point to the element after the last. Well, it's not so it can potentially it can be defined not in terms of the member functions, but in terms of three functions that are that operates on the container. It's semantically it would be the same, and this approach was proposed initially by Stepanov, but it was rejected because in that time, in 19th, people strongly feel that object-oriented programming is our future, and they want everything to be a class. But this approach is more general with the free functions, because for example, if you follow this approach, you can model C arrays as containers, and for the current approach, there is no way to model them as containers. But now from C++11 there is finally free function begin and end, and from C++ 17, I think there is also size, but okay. There are two types of containers in the library: sequence containers and associative containers. Well, basically, there are 5 template classes that models sequence containers: array, vector, deck, forward list, and list. So array represents the data. So container with the fixed size, with continuous data. Vector, the same thing by dynamic. Deck is double-ended queue of basically a list of blocks, a list of chunks of data. So for forward list and list, they are easy. So let's start with array. So array provides the same functionality as C arrays, but they're better. You can, unlike C arrays, you can return std array from function. And also, arrays are like tuples. You can think of them as of tuples of the elements of the same size, and the interface and they share with tuples the interface. To get the element, you can use std get. You can query the tuple size, and you can query the type of the element. Note that here I don't have template parameters for the std array. It's because template parameters deduction of the C++ 17. You can do that. And from the other side, arrays are true sequence containers, and you can use them with algorithms like sort, for example. Hmm?
What is the advantage of using the tuples now? What is the advantage of using the tuple methods on an array?
Okay, the advantage is that you can write the same generic code that is applicable both for tuples and for arrays. And for example, if you already have a code that takes a pair or takes a tuple of two elements, you can, and this code works, you can pass array of two into it, and it will work as well. So vector. So vector has dynamically allocated continuous data under the hood. And additionally, additionally it holds the actual size of the data and the size and the size of requested allocation. And each time you are trying to push back to expand your vector, and the new size exceeded capacity, vector will expand, will allocate the new vector will relocate the data and double the size. So in this code, how many times? Double the size, and all elements of the data will be moved to the new allocation. So in which code, how many allocations? How many times each element will be moved to the new allocation in average?
Most elements maybe log 2n. Most elements log 2n times.
Well,
or close to that number.
In average, 2 times. Well, this basically means that that it's quite cheap. So vector. So the standard guarantees that all data so the data allocation is continuous. So you can you can easily so you can use vector if you have some API inherited from C, like that. You have some function getResult that just fills the buffer, and before you should check, you should query getResult size to get the required allocation. So you can easily do the wrapper for that C function. So first we allocate the vector, and next we just provide we can just access the raw data of our raw allocated data with the data method. Well, it works in most cases, but not for Boolean. Boolean. So vector bool specialization is different. It doesn't provide this continuous storage guarantee, and also it is not even thread compatible. So, and it was added to the library as a proof of concept that you can specialize data and you can use proxy and also it illustrates how to use proxy objects to access the data. But the practical advice: don't use vector bool unless you know what you are doing. Okay, deck. So this is how the data is organized. You have
is it only for the vector that we cannot use the Boolean, or is it also for the other containers?
Sorry?
Is it only for the vector with the Boolean?
Yes, only for the vector.
So array and all other containers can be used?
Yes. And well, in deck you have some table of contents that holds the reference to the chunks, and all data is stored in the chunks. And it's it provides. So if you want to expand your deck, you don't have to reallocate your memory. You just add the new chunk if it's needed, and you can add it. So you can add it either from the tail or from the head. Doesn't matter. But the disadvantage, so push back and push front are yes. So it's important to understand that for the vector, each time you do push back and your vector iterators can be invalidated. So your vector iterators are invalidated. So because how iterators in vector are implemented, they basically nothing but the pointers to the particular element, because the data is continuous. And if you reallocate, obviously pointers are became stale. But for the deck, your iterators are not invalidating during the push front and push back. So there is also list. Well, it's implemented like as a classical double-linked list, and so each one thing for the deck, that for the random access you need to do two dereferences. You need to look first to go to contents table and then to your chunk. Lists for the list you are doing a lot of so for each element you store 2 additional pointers, so it's quite expensive, but you can have very fast insertions and deletions, and also it has splice method, so not even one but several, but it is useful when you want to concatenate concatenate the list. So it's basically all one operation, because you just link the corresponding pointers, and there is no random access, obviously. But the good thing that all your iterators are never invalidated. And some algorithms are implemented within the list class. Okay, what to use and where? So as a default, you should use vector, if you can, because it's the fastest and it consumes less memory. So if you have something that is like a queue or stack, you should use deck because of cheap push of cheap pushes. And if it's important for you to, and if you store iterators, and it's important to you that iterators are not invalidated, then it's safer to use list. But it's very ineffective. Okay, associative containers. There are several of them. So set is so unlike sequence containers, they store the data in the requested order. And they have effective lookup operations. So set is designed for so the most generic is map. It's just designed for storing key value pairs. If the value is also if the value serves as a key, you can use set. With multi-set, you can it's a typo. And with multi-map, you can store several key value pairs for a single key. And you have the same thing for unordered, and you have unordered variations. So the difference is that, for example, map is implemented as a binary tree, and it requires requires the order to be defined. Unordered map are implemented as a hash table, and it requires equal operator from the key type and also hash function. If you want, you can you can provide your own comparator for the associative containers, or for those that are not or alternative hash and equal functors for unordered variations. And it's important that your compare factor should be same. So that it should reflect the real order, but it's easy to mess up with. It's very easy to mess up with the comparison functions. And for example, if you or from equality functions, if you don't make them, I don't know, transitive, for example. And for the set, it's important that the data should be virtually immutable. You can have, for example, the set of strings, but you don't. But you can't modify those strings if they are already in the set. Otherwise, it will be undefined behavior because, well, they already serve as a key. Yes. Okay. So you can do insertions and lookup for the map with several ways. So let's assume that you have that map that maps strings to integers. We can insert element by insert method. We can modify it with the add, and we also have this bracket square access operators, and they are they will create the element under the requested key if there is no this element. Otherwise, they will provide the reference to the element. So this code will be will return that. And
no, I'm not sure. Like the third line where you have add.
Yeah.
As far as I remember, the add doesn't allow you to do assignment, right? Because it returns copy, I guess.
No, it returns reference.
Yeah.
Yes. Depending on the context, it returns either const or non-const reference. But you see this commented line.
Yeah, the third one is like you said, like the output D should be 22. So like I assume that means the third line compiles.
Yes, but you see this line that is commented out.
Yeah.
This, if we will uncomment that, it will be an error. Why? Because there is no E element in the map. And add method doesn't add the element for you. Like, for example, M G does. Sorry. Okay, so people always get confused that set doesn't have contains method, and usually some people write the code like that to check if the element is in the list. In the set they compare the iterators, but you can. But actually count method serves as contains. So as I said, STL library has a lot of algorithms. I don't want to go in details. You can find so the documentation is very clear, and you can find a lot of them. Just I have some random notes about how to use them in some confusing situation. Okay, we have remove algorithm. What do you think? Will this code succeed? Okay, the answer is no. Because algorithm doesn't remove because remove algorithm doesn't actually remove anything. It moves the desired element to the end of the iterator range, and it points to and it returns the iterator that points to it. So the right way to use remove is the following. First you apply remove, and then you erase the elements under this iterator. Then it works. Okay. There is also a tiny but important algorithm, swap. And it is expandable. So you can add, if you add some type that and STL doesn't know about the type, you can specify your version what to do with the swap. By default, swap do the right thing, of course. It moves one element using temporaries, but in some but say you have this class, and you don't want, for some reason, to do the swap. So, and you try to test it, and the test will fail. So STD swap will still swap. The thing is that this is not idiomatic usage of the swap. To do it right, you should use STD swap before. You should add this using STD swap before the actual usage. Then swap will be then compiler will use ADL lookup. Yes.
Sorry, why do you have to define this swap function a friend? I don't get it.
Yes, this is also important. From C++ 11, you can have friend definitions, and it has special meaning. This, if you do that, this function will participate will participate in ADL lookup only if one of the argument is A, for example. So so in a simple words, this swap is not really visible from others. So it's only can be applied when the argument is exactly A. But but you're right. We can do this swap. We can in this example we can define this swap out of the A scope without friend. It will not change anything. Okay, now this will work as intended. Also,
Can you explain again using the namespace?
So, what is what is going on here in this swap? We have A and B. They are of the type A, and we apply the swap, and we exactly specify that we the namespace. This is std swap, and this will trigger the swap that is defined in an std that does actually the swap, and our swap will not called. But but if you inject the std swap in this function, now this swap doesn't have namespace qualifier, yes, and compiler will do ADL argument-dependent lookup. So it first, so what argument-dependent lookup is? So first compiler will check what are the argument types. The types are it's A, yes. Then it goes to the functions that are called swap, and they are applicable with A, and it sees this swap, and it has the preference against the std swap because of arguments. And And here if we are swapping just booleans, compiler will still use std swap. Okay. STL contains also useful container adapters. Queue, stack, and priority queue. So, but they are obvious, but it's good to know that you have, but that they are in STL too. Okay, so with the new features that were added in C++ starting from 11, they were also driven by the STL design, and they overcome some inconveniences that were in STL usage, and as a result, now the usage is much more intuitive. You can do your initialization just from initializer list, like you do in the C arrays, and here you will have automatic conversion if it's not narrowing. You can easily empty the container by doing this, and this works for all containers as well. Quite convenient. You can skip the template arguments because of template deduction from C++ 17. You can rely on the order of initialization in the initializer list. So this vector will be initialized with 0, 1, 2, for example. Yes, and you can also and the initializer list can be nested. This is also convenient. You can define, for example, set of vector and initialize it in one expression. One useful use case, for example, if you have this function that takes vector, you don't have to create this vector implicitly. Just pass initializer list and conversion will take place. Also, with move semantics helps a lot. So before C++ 11, the requirement for the types that are stored in containers was that they should be copyable. Now it is softened. Now types are only required to be movable. And this is extremely important because now you can use std unique pointer as an element of container. And this serves the use case where you have uncopyable objects that you want to store somewhere. Yes, and and even though even though vector does reallocation, your data will not be copied. It will be just moved to the new place. So, and because of that, there is no more reason to deal with raw pointers. Just don't use them. And also, now we have ranged-based loop syntax. And this change was also driven by, explicitly driven by the STL library design. So all containers do support that. Also perfect forwarding works nicely with STL. And
oh yeah, thanks. So about the fact that the elements has just to be movable, is it for this reason that in one of the previous examples you use the auto in the range for auto element in map or whatever? You use that with the R value reference.
Let's see.
I don't know. It was a few examples before. I mean, I think was related with std map. Yeah, here.
Ah, here. Huh.
You use for auto.
Well,
and
it's not really R value reference. It's basically perfect forwarding. Another. So it's universal reference. So and by the way, it's good to. It's kind of best practice. If you are writing range-based loop, by default use this syntax, because what does it mean? That it doesn't matter what elements, how the elements are dereferences. If the dereference is the reference, V will be the reference as well. If it is value, it will be value. So it just forward the behavior of the references.
Hi, I just had a question about that auto as a perfect forwarding usage. Compared to, say, using auto with a single ampersand to get a regular reference in loops, say, that aren't modifying the container, is that, I guess, is that still a reasonable practice?
Yes,
yeah, okay.
But in the case of STL containers, of course, because they all return by reference. But in principle, you can have something that works that allows you loop range based for loop that returns by value. And in this case, it's better. So in this case, you cannot use auto reference.
If we have a const auto reference, would that not keep the lifetime of that temporary throughout the loop? For example, if I had a range based for for a container they returned by value. And my loop said, for const auto ampersand colon this thing. The temporaries I get back from each of the iterators in that container, does the const auto reference extend the lifetime of that temporary for the whole loop?
Yes.
So in that sense, that sort of mechanism is still safe,
Yes.
even in the value returning. Yep, cool.
Well, frankly, I'm not 100% sure about that.
Fair enough.
So there are, I do remember that there are corner cases about that, it's much easier to solve it case by case, I think.
Right.
There's no general recommendation.
Very good, thank you.
Okay, so perfect forwarding is also works fine. So now we have overloads for the pushback that supports moves, and also we have emplace back additional function. And emplace back takes the arguments and constructs the element. In this case, it will be no copy of the A element in both cases. When we use pushback, we will do one move copy, and for emplace back, we will not do any move and any copy. The data will be constructed in place. So that's it about STL. Any questions?